Welcome back to the shop and to the channel. Some months ago, I picked up this Sanford 6x12 surface grinder from a local industrial surplus reseller. And the only thing I've done with it is turn on the motor just to see that it was working. And it was, but it made a god-awful noise. And I need to pull this motor to see what it might be the source of the noise. Am I going to have to replace the bearings or what it might be? So my task for today is to at least get this motor off of the back and take a look at it, maybe clean it up a bit, and see if there might be something I'm going to need to order to take care of the issue, and if we can take some other parts of this machine apart, then I will, at least in an effort to get it a little bit cleaner. Well, the motor is only attached to this plate here with 4 screws, but there's also this strain relief for the power cable. Now, the insulation on this cable is pretty crispy. Yeah, it's definitely going to need to be replaced. All I should need to do here is to remove these 4 screws, and then I should be able to angle the motor around the drive belt. Well, like I said, the insulation on these wires, you can see here, it's actually broken off inside, is all pretty bad. So I'm just gonna just cut these wires because I'm gonna replace all this, and I think I'll eventually replace these wire nuts. I prefer to use ring terminals and nuts and bolts for motor wiring in these machines. They're less likely to vibrate loose. I'll clean off the tag here, and we can see that it's a 3/4 horsepower motor, and it runs at 3450 RPM. And it looks like I could make this a 440 wiring as well. So I should be able to find bearings for this if they are in fact part of the issue. But as I look at the back of this thing, I'm not so sure that it's bearings. This fan that attaches to the back of the shaft is loose. It's spinning on its own. So it is possible that that was the source of the noise all along. But for me to be sure, I need to go ahead and take off this cover off of the back. There's these really long bolts that go all the way through the frame of the motor. I don't want to disassemble the motor yet if I don't have to. So I'll start by taking off this cover and then getting a better look at the fan and how it attaches to that shaft. Well, with the nuts for those end bell screws removed, I'm not taking the whole screw out. I can take this cover off, and my goodness, this thing is absolutely caked and packed full of grinding dust. This thing has seen a lot of use and probably abuse. Yeah, I'm gonna get this cleaned up here because this is pretty bad. And this fan here is just kind of spinning loose on the back of the shaft. I don't see any evidence of like a set screw or a key, so I'm not 100% sure as to what keeps this in place. But there is a snap ring on the end of the shaft here that looks like it does hold the fan on. I'm going to get that off so I can take the fan off, and then that might give me a little bit more information. I do hate these snap rings though. They are such a pain. One of these smaller snap rings are always seem to be the hardest. Now I can take that fan off, and yeah, I don't really see anything that would physically attach it to the shaft. So I'm not sure what keeps it spinning. Now there is this wavy washer back here. That might be something. And then there's another snap ring on the back. Yeah, there's no like keyway or set screw for this fan, but I have the feeling that what was holding it there was just friction between the snap rings and the wavy washer. But I think all this grinding dust was interfering with it being able to do that. So what I really need to do is clean this thing up. It might still be an issue, but I think once this thing is clean, I might end up with a different result. Well, and in just the off chance that I'm going to have to take this thing apart, I might as well go ahead and take this front pulley off, if for no other reason than to make it easier to clean this motor, as well as, you know, clean this pulley. It's got a little bit of rusting on a spot, and we'll clean that up on a wire wheel. Well, I spent a little bit of time with some super clean degreaser, and I've got this thing reasonably clean. It is far from perfect. There's still some stains on it, but I'm not too worried about that. I did want to get the bulk of this grinding dust cleaned up, and I think I've done that. So far I have not disassembled the motor. I don't know that I'm going to do that just yet. I think this motor comes off and goes back on easy enough that once I get the rest of the surface grinder cleaned up and I get the motor back on, we'll get it fired up. And if it is still creating a bunch of noise from that fan, then I'll revisit this. Well, with the motor cleanish, that fan actually fits on the shaft a lot better. I'm not sure, again, if it was just all of the grinding dust that was interfering with this thing having a friction fit, but with everything reassembled, I don't know that that fan is going to be a problem. I won't know for sure until I get it powered up again, but I am optimistic. And I think for now, I'm just going to take all these wires and stick them back into the pecker head. I've got some new power cable, 4-conductor power cable coming. And when that comes in, we'll get this all wired back up with new cabling. Well, since I chose not to disassemble that motor, I might as well spend a little more time disassembling the rest of the surface grinder. I am going to take some of these parts off of the surface grinder. I don't know how far of a full disassembly I'm going to take this to, but for now we'll go ahead and get the magnetic chuck off of it so I can take a look at the elevating screw, which I know is in pretty bad shape. Well, in order to get to some of this stuff, I need to take the front cover off of the surface grinder, including this wheel guard, as well as the sheet metal that goes over the top and on the front. Well, in the back here, there's 4 screws that hold the motor shelf to the, I'll call it the spindle carriage. There are also a couple of screws back here that attach the elevating nut to the back of the spindle carriage. Now I can remove this nut that holds the elevating lead screw to this bevel gear. Well, one of the other areas of concern for me is this elevating lead screw and the nut. Let me get this nut off of here and I'll try to show what I mean. Well, you can see here in this section of the lead screw just how badly worn it is. I mean, it is probably 60% gone in the center when you compare it to the other threads. It's really hard to tell looking at the nut as to whether or not it's worn as well. I suspect it's probably got as much, if not more, wear than the lead screw itself. Well, looking at the lead screw, if I'm going to look at replacing it or at least repairing it, I need to figure out what the pitch is. So I'll set my calipers here to 1 inch, and we'll set this over the threads and see if we can't count them. Well, and it's pretty obvious if you look close that it does not appear to divide into 1 inch evenly. Well, it's a 3/4 inch shaft, and it's an imperial machine, so I don't think that this is a metric pitch. There's got to be something else. Well, I just need to think on this. I'll come back to this later. I think I've got an idea of what's going on here. In the meantime, I want to take off the top half of this elevating mechanism. On the handle, there's a pinion, and that pinion drives the bevel gear, and then of course the bevel gear is what drives that elevating lead screw. Well, this thing is held in position with a couple of pins, so I've got a wood chisel here to try to get me a little bit of separation so I can pry it off of the top of the column. Well, with this bit now up on the bench, I can go ahead and tap out this roll pin that holds the pinion gear on the end of the shaft. Well, this pinion's on here pretty tight, so I need to use a punch to go ahead and drive the shaft out through the pinion. Well, that'll get the shaft off of the pinion gear. So now I can slide this whole handle out of the top casting along with this spacer. And with that pinion gear out of the way, I can lift off the bevel gear, and underneath the bevel gear there is a thrust bearing, a roller thrust bearing. I think that's what they call these. Well, now that I have all of the components to the elevating mechanism off of the surface grinder, I can take a little closer look at what I have here and what my options are to repair this. And then measuring the bevel gear and the pinion, and then counting the teeth, the pitch of this elevating screw turns out that it's 6 2/3 TPI. You see, the hand wheel is calibrated in 50 thousandths per rotation. So one rotation of the hand wheel is supposed to raise or lower the spindle by 50 thousandths of an inch. Well, the bevel gear here is 48 teeth, and the pinion that's attached to the hand wheel is 16 teeth, which makes this a 1:3 gear ratio. That means that if I turn the hand wheel one rotation, I'm only turning the bevel gear and in turn the elevating lead screw 1/3 of a rotation. Which also means that if I want to turn the lead screw one full rotation, I have to move the hand wheel 150 thousandths, or 3 rotations. Well, if you divide 1 inch by 150 thousandths, you get 6 2/3. And do you know what they don't make in standard pitches? 6 2/3 lead screws. Not to mention, I don't believe this is an Acme thread. It looks like it's a square cut thread. So I don't know exactly what I'm going to do here yet. Well, what I do know is I am out of time in the shop this week, so I'm going to have to end this video here. I've got a few ideas that I can do here. None of them are great, but they'll all be semi-workable. I'd like to take a quick second to thank all of the subscribers, and especially those that support the channel on Patreon or PayPal. Thanks for watching, and we'll see you on the next one.